Here we have some more molecules to determine whether they are aromatic, anti-aromatic, or non-aromatic. So all of these molecules, let's see, they are conjugated. Notice that we, except this one is not. We have here in this system, conjugation is interrupted by the nitrogen, even though this looks like a little like cation. You cannot do resonance over to the side because you will be expanding the octet at the nitrogen. So it's not. But also, if you notice, this molecule has 4 pi electrons, but the main thing is that it's not fully conjugated because, again, at movement, if you did this, you will be breaking the octet rule. So a conjugation is interrupted, that movement of electrons is not allowed. So it's not fully conjugated. That actually explains that this, why this compound is very acidic. So if you did this, say, with, see that we have a base here, and a base. And you get that, I have a base, and you get that electron. So I'm just drawing an acid-base reaction. What you're getting is the conjugate, this is the acid. The conjugate base is actually pyrrole. Pyrrole. And you're going to get, say, base, and that will have an H. So conjugate acid, conjugate base. So notice this compound, as we determined before, is conjugated, is cyclic. So everything here is sp2 hybridized. So fully conjugated system. Conjugated cyclic is planar, and 4m plus 2 electrons because we count those. These are delocalized. So pyrrole is aromatic. We can do resonance here, right? So in doing so, when you do this resonance structure is simply a tool to explain that electrons are delocalized. But we have determined here then is that it's conjugated, cyclic, planar, 4m plus 2, so it is aromatic. So when you're doing the acid-base reaction, notice that pyrrole is much more stable than the conjugated acid. So the pKa for the conjugated acid of pyrrole is actually 0.4. So very acidic. If you guys recall, for example, pKa of hydrochloric acid is -7. So pretty acidic. If you have hydronium ion, it's -1.7, and so on. But if you have, say, acetic acid, it is 4.7. And so this compound, the conjugated acid of pyrrole, is much more acidic than acetic acid. So, and it is so because this molecule, as is unstable, and by losing that, that proton, that extra proton, becomes an aromatic. That's an aromatic system. So much more stable, and thus the equilibrium is very much shifted to products. That's why I'm drawing those lines. So now we can use these concepts to explain reactivity. Here we're explaining acidity of the conjugate acid of pyrrole. Now let's analyze this compound here. What I have below are all heterocyclic compounds as well, meaning that we have another element that is different than carbon as part of the cyclic structure. So what we need to know is if we count the electrons in the lone pairs, what electrons do we count? So as we determine in pyrrole, these electrons you count because these are on a p orbital. So you count here 2, 4, 6. In the case of pyridine, I'm going to draw it. It is in another video. We have determined that the lone pair here is localized. Lone pair is localized, so you don't count those. You count 2, 4, 6. Now, which electrons do we count? So this system, all of these, think of electrons being allelic. So what happened is we're going to say that oxygen atom is also sp2 hybridized. So you will have one lone pair delocalized, and the other lone pair is going to be localized. So you do resonance only with one pair. So you count one of the lone pairs. So you count 2, 4, 6. And same thing here. So sp2 hybridized, you only count one of those lone pairs. So the one that is delocalized, so 2, 4, 6 pi electrons. So conjugated cyclic planar, it meets Hickel rule for n equal 1. So another aromatic, this compound is furan. This compound is thiophene. And this is indole. Let's see what is, this was pyridine. So what electrons do we count here? So this part of the molecule, notice, is similar to pyrrole. So that's like pyrrole. So we know these electrons are delocalized, so we count them. So if you see that, the total number of pi electrons, these are noticed sp2, sp2, so all of these have p orbitals that can overlap. sp2 all over, including the nitrogen. So it's fully conjugated. It is cyclic planar. How many pi electrons? Now we count those. And so we say 6, 2, 4, 6, 10 pi electrons. So that means Hickel rule for n equal to replace that in that equation. So remember that n always is an integer. So indole is also an aromatic compound.